This is number 82, chapter 4, looking at, again, precipitation reactions, but now looking at ionic and net ionic reactions and those representations of precipitation reactions. And so number 82 reads that lead 2 ions, and so that would be lead at a +2 cationic state, can be removed from solution by precipitation with sulfate. And so if we combine those two, we have +2 and -2, so we would precipitate lead 2 out using sulfate. We would precipitate it into the form lead sulfate. And so we suppose we have a solution that contains lead nitrate. This would be lead 2 nitrate, so we would have this formula for it. We need to write a complete ionic and net ionic reaction to show how aqueous lead nitrate reacts with aqueous potassium sulfate. So we're talking about reacting with potassium sulfate, and then that actually produces our lead sulfate as a solid, and it also is going to produce potassium nitrate. Our potassium nitrate is going to be aqueous, our lead sulfate is solid, our potassium sulfate is aqueous, and our lead 2 nitrate is also aqueous. So that is just our general precipitation reaction, showing that we do actually make a solid precipitate, lead sulfate. But what we want is the total ionic reaction and the net ionic reaction. So first we'll start with the total. The total ionic reaction, basically we want to represent all ions. All ions, all positive ions, all negative ions, as well as all spectator ions. And so we would have lead +2, that's aqueous, and we would have 2 nitrates -1 that are both aqueous. I just took lead 2 nitrate and split it up into its individual ions, and we can do the same thing for our potassium and our sulfate. And so those would be all the starting materials in their ionic form. And then those are going to react to form lead sulfate, which we are not going to represent in the ion form. We're going to represent it as it is as a solid, because that's what happens. It precipitates out. It's not aqueous anymore. And then we still have 2 potassium ions that are aqueous and 2 nitrate anions that are also aqueous. And that is our total ionic reaction. We're showing every ion that is present. We're showing them separate in their positive and their negative forms. The only one that is not in that ion form would be the precipitate lead sulfate, which is a solid. So that's our total ionic reaction. And so for our net ionic reaction, we don't show spectators. We do not show the spectator ions in this form of the precipitation reaction. So for the net ionic, we are just writing the ions that actually react, which would be the lead +2 and the sulfate -2 that are both aqueous. They react to form lead sulfate, which is a solid. And so that is our net ionic reaction. We are not showing the nitrates. We are not showing the potassium on either side of the chemical reaction because, again, they are not forming anything new. They are simply staying in solution and are simply spectators, simply watching the show, and the players in the show are represented in the net ionic reaction. That's number 82.